Recording in progress.
Electric power, and remember that this is somehow what the project is going to be related, so it is important that you may be paying attention to this. The first example we already did. I deleted. We already did. I deleted, but I guess I finished. I don't remember. So it is about the electric space heater that is connected to across a 100 volts outlet. Okay. So according to the information given in the problem, you will choose the equation. Okay. So in this problem, they are giving us the outlet at which it is connected, and the outlet, the unit in which it is measured is in volts. Okay, so that means that this is the potential difference or the voltage. Then it says that it dissipates 1320 watts of power. So they're telling you it is power in the form of electromagnetic radiation and heat. Calculate the resistance of the heater. So these are the only two givens, and they're asking you to find the resistance. What equation will be more accurate to use? I have potential difference, that is 120 volts. I have power, that is 1320 watts. So what is going to be the equation to use to find the resistance? Remember, the resistance is measured in ohms. I have three equations here, A, B, and C. Which one is better for us to use? Look guys, I cannot use the first one because they're asking me current. I don't have current. Okay? Now, I do have this equation, okay, that allows me to use current. I mean to find current, and then I can use this equation to find the resistance. So that means that I can do the problem in two steps. Yes, you can do it like that. Or you can do it directly with the last formula. If you apply this formula, if you apply this formula, you can do it directly the isolation and just plugging in the givens. Doesn't matter which one you use, okay? It really doesn't. So you can do it. I'm gonna do it with the two ways, okay? And the first way, that is, I'm going to write the equation. Power is equal to potential difference squared divided by resistance. Isolated resistance will give us delta V to the second power divided by the power. By plugging in the givens, you would obtain 120 volts to the second power divided by 1320 watts. This should be 10 point something. How much is this?
$10.9.
10.91 rounded. 10.91 rounded. Remember, we measure resistance in ohms, so that will be the final answer. You can do this way or you can do it in another way. The second way is doing a two-step process. Okay? So if I want to use the first equation from here, I need to know the current. These are the equations for me to find current, okay? If I take this first equation, I have power and voltage. If I take the second equation, I have power, and I also have resistance. I can either use one or the other, okay? I can use one or another. Doesn't matter. Ah, no, se supone que ando buscando resistance, so I cannot use this one. I know the resistance now because I found it, but supposedly you don't know it. So I'm going to use the first equation, okay? Uh, Finding current, and once you have current, you can find the resistance. So current is equal to power divided by the voltage. By plugging in the givens, current is equal to power, that is 1320 watts, divided by the potential difference, that is 120 volts. This current how much is this?
Yeah.
11. As a reminder, okay, uh, in the presentation I told you what 1 watt is equal to. Do you remember? Watt is, I mean, we measure power in watts, and watts by definition, I mean, power by definition is the rate at which work is done. That means that watt is equal to joules per second, okay? And voltage, voltage is equal to, well, there are many equivalences for voltage, but one of them is Newton Coulomb or joules over Coulomb, okay? So you have watts joules per second and volts that are joules over Coulomb, okay? So how, in what units do we measure current? We measure current in amperes. In amperes, it has an equivalence, okay? Here, when you divide these two, joules and joules will be cancelled, okay? So you will have 1 over second divided by 1 over Coulomb, okay? So here you do the sandwich method, or FOIL, the word you prefer to call it. So coulombs up, seconds down, and coulomb per second is what we know as 1 ampere. So this is how we obtain amperes. Or you can just write directly amperes and it will be just fine. Now we'll delete this because I was just giving you the demonstration of the units that are equivalent. Now once you have the current, you can find the power, okay? What equation you can use now? The first one, the one that says power equals current times voltage. Sorry guys, I got the flu. Every week is the same. Okay, so this will be your first step, and this is gonna be your second step. Okay, now that you know the current, you can find resistance. Okay, now resistance gonna be equal to, by knowing the current, you can say power is equal to current squared times resistance. So resistance, the isolation of this, is going to be equal to power divided by current to the second power. Sorry, you're not. Yes, you're seeing it. Plug in the givens. How much is this? Should give you the same answer.
10.81.
10.91. Since this is resistance, gonna be in ohms. So as you can see, it doesn't matter what path you choose. You can either choose one way or the other. The final answer in the end will be the same. So when you don't know what equation to use, just know that you can use direct equations, or you can do a more step process, or you can do isolations, but in the end, the two answers are gonna give you the same. There's another problem here that says the potential difference across a resting neuron in the human body is about 70 MB. Everyone were asking me the other day about the prefix M. The prefix M is milli, okay? And the prefix, this other from here, is those are micros, okay? So this Greek letter mu is the prefix micro. Now the equivalence for each is milli is times 10 to the negative third power, and micro is times 10 to the negative 6th power. Keep this in mind. Do not forget. You can find this in page 12 from your textbook. Now, it says the potential difference across a resting neuron, it's about 70 millivolts. Okay, so I'm going to start writing my givens. Potential difference, 70 millivolts. You know that we can do the direct conversion by just replacing milli by its equivalence. So this will be 70 times 10 to the negative third power volts. And the current in it is approximately 200 microamperes. So they are also giving me the current. It says 200 microamperes. Replace the prefix micro by its equivalence, and it will be 200 times 10 to the negative 6 power amperes. How much power does a neuron release? I need to find power. Okay, so let's see. I have voltage and I have current. Let's see what equation I can use. Well, it is there. It is already highlighted. The first one. Power is equal to current times potential difference. All you have to do is write in the formula and plugging in the givens. Power is equal to current times potential difference. Plug in the givens. Remember what ampere means?
Coulomb per second.
Okay, got an answer. Ash, ash. I got 1.4 times 10 to a negative fifth power. Power is measured in watts. This will be the answer. Okay. Now this watts is coming from the definition of ampere and volts. Okay. You are multiplying ampere times volts. Ampere, by definition, current is how much charge passes through a given area in a second. So it is Coulomb over second, and you're multiplying times the voltage. Okay. In the voltage, what we have is joules per a Newton meter over Coulomb or joules over Coulomb. Okay. So coulombs and coulombs are cancelled. And remember, by definition, joule per second is what we know as watt. That's where the unit is coming from. I can leave this here or delete it. In this part I deleted because of the space it was taken, but I'm going to leave this here. And that's it. That's the answer, guys. It's not too complex, as you can see. I don't know if at this moment you have a doubt. Okay, I will continue. I was just checking the list again. because somebody left. Okay, in 1894, a group of students at Lawrence Technological University in Southfield, Michigan, built a car that combines a conventional diesel engine and an electric direct current motor. The power delivered by the motor is 32 kW. I guess that you know what the prefix K is because we use it a lot. If the resistance of the car circuitry is 8 ohms, find the current drawn by the motor. So the power in this problem is 32 kilowatts and the resistance is found to be 8 ohms. It says that you need to find the current. So these are the givens. The power is 32 kilowatts. Remember that the prefix kilo is times 10 to the third power. So the conversion will be 32 times 10 to the third power watts. Then it's giving you the resistance that is 8 ohms and it says that you need to find the current. What equation I have to use to find current? Let's see. I have power and I have resistance. What equation am I going to use? I have power and I have resistance. Should I use A, B, C, D, E, or F? I have power, I have resistance, and I'm looking for current. So this is the equation to use, E, okay? Because it is all, I took the equation E from this formula, okay? This one is already isolated for the current. So current is equal to the square root of power divided by resistance. So that's the equation to use. Power is equal to current squared times resistance. If you are looking for the current, the isolation will be current squared equals power divided by the resistance. And now to get rid of the power, you get square root at both sides of the equation. This one here gets cancelled, but the other one remains. So this is the final isolation, okay? Now all you do is plug in the givens. Power, that is 32 times 10 to the third power watts, divided by the resistance that is 8 ohms, okay, I got the current 63.25. Now, in what units do we measure current? In what units do we measure
Ampere.
in amperes? Okay. Now, you can see the application of the formulas are very simple. The isolations also are very simple. The more complex thing that you have to do is isolating voltage from here or current from here, and these isolations are already done for you. Now, I need that you practice this topic, so you're going to work right now in the practice problems from the page 607. I will project the exercises, but then you continue in your house. This is in page 607. So practice this topic because next week we're gonna have we're gonna have the quiz. Okay? I know that I already assigned the homework for this week, but uh, practice this topic because it's coming in the quiz. Now, if you want to know, if you want to be sure about the answers, these are the good answers. Okay? Just compare that what you get is good. So I don't know if you want me to project the exercises or the formulas, or I can do both. I can do both.